What you're about to witness is the most grainy video on earth. Enjoy.
Welcome to the bare minimum pool. I'm its new owner. Hold up, this pool's kinda huge, but looks kinda dirty. I should add in some chlorine.
Hey, wait, sir. Do you know what you're putting into this pool?
Who are you?
I'm Captain Brian, and I'm here to teach you about the equilibrium in this pool. Hey, come down from there. I'll show you.
Okay.
Okay, so first step, we gotta take 2 samples from this pool water. Okay, now that we're back at the lab, let's put these 2 samples in here and in here. But first, before we add the chlorine, let's talk about the history of chlorine.
Before chlorine was used to sterilize pool, most swimming pools were filtered to keep them somewhat clean. However, this method is very costly because the pool would need to change water frequently. By the 1890s, chemical producers started looking into bleaching powder, which is calcium oxychloride. Bleaching powder is formed when chlorine gas reacts with lime. The first person to use chlorine to disinfect potable water was Sims Woodhead, and the first to regularly use chlorine for potable water treatment was at Jersey City's Boonton Reservoir in Boonton, New Jersey in 1908. By the 1900s, engineers had perfected chlorine infiltration.
The first to use chlorine to sterilize a pool was at Brown University in 1910. John Wyndham Miller Bunker, a graduate student, sterilized 70,000 gallons of water at Brown University with chlorine. Bunker applied hypochlorite of lime, 2 liters of pool water at a concentration of 1 ppm, and the pool remained sterilized for 4 days. By the middle of the 20th century, compounds consisting of chlorine with cyanuric acid became widely available for swimming pool use. When the combination of dichloroacetyl cyanate and cyanuric acid stabilizer is used correctly, it will provide long-lasting chlorine, good solubility, and will not affect the pH level. In today's pool, people use a combination of chlorine-containing isocyanates pressed into slowly dissolving tablets for steady, long-term chlorination.
Okay, now that we're done exploring the history of chlorine, let's actually add it. Oh wow, look at this. The chlorine is being mixed into the water. When we dissolve the chlorine into the water, we can model this with the chemical equilibrium equation. Cl2 gas plus H2O liquid yields HOCl aqueous plus HCl aqueous. So, when the equation reaches equilibrium, the reaction will be moving at the same rate forward and backwards. This would mean that the products will be creating more reactants to replace the reactants that are lost and vice versa. This essentially means that the amount of chlorine in the pool will be the same over time because at a chemical level, HOCl and HCl will continue to make more chlorine gas, or Cl2, and H2O to stay at equilibrium under an ideal, perfect pool. Okay, now that we got the specifics done, let's wait for this equilibrium to occur.
Eventually,
Look, it worked! The reaction was able to reach equilibrium to become the pool water that we know today.
so why is this important for the real world? Well, pools without chlorine have no resistance to bacteria, disease, and algae growing in it. This is what a pool without chlorine would look like. This does not look pleasuring to swim in. Aside from the obvious algae, it also would not be able to fight off disease, and while it may not immediately make you sick, if everyone swam in it, and even 0.5% of the population did get sick, it would spread exponentially because other people are using the same pools without any disease resistance. Chlorine is important for protection from disease, both the creation and spread of it. How does the equation factor in though? Well, without the equilibrium equation, the amount of chlorine to add would be much harder to determine. While too little chlorine doesn't offer much protection because when there are germs and algae, the chlorine leaves the equilibrium equation to eliminate those threats, which lessens the amount of chlorine in the system, which is why it's important to add more. Too much chlorine is also bad for you. Scientists have used this equilibrium equation to be able to have a set amount of chlorine to add to pools. For a personal pool, for example, there are chlorine floaters that you put large tablets into, which disperses the correct amount of chlorine into the system over time to keep the equation balanced. To sum it up, we add extra chlorine to keep the equation at equilibrium despite chlorine leaving due to the germs and algae pulling it out of the system. Chlorine is absolutely paramount to keeping our pools safe, and our pools would not be safe without knowledge of this equation.